Good morning, students. In previous class, we have seen the structure of atom. The concept of structure of atom has been proposed by different scientists like John Dalton, Rutherford, and Neil Bohr. The Rutherford and Neil Bohr has proposed the structure of atom very clearly. According to their concept, the atom is consists of central part which is known as nucleus. In the nucleus, positively charged protons are there and neutrons. Around the nucleus, the negatively charged electrons are revolving in a specific energy level. This energy level, they called it as orbit. Okay. Now, today we will go for the de Broglie's wave method or de Broglie concept of the microscopic particle. According to de Broglie's, the de Broglie's in the year 1924 proposed the concept of dual characteristics of electron. Now I am sharing this here the concept of de Broglie's. I will explain by sharing the screen. Okay. Now, according to Louis de Broglie was a French physicist. He proposed the idea about the dual characteristics of electron. In the year 1924, he proposed that all the microscopic particles which are having the dual characteristic, so electron, proton, neutron, all these are also the microscopic particles. So these are also having the dual characteristic. Now, if waves can have particle-like characteristics, so similar concept can be applicable for the microscopic particle like electron, proton, neutron. So he proposed the concept of dual characteristics to the electrons. So electron have wave-like motion because it's a particle. So electron which is revolving around the nucleus, just we will see here, in a specific energy level. This specific energy level, which we are calling it as orbits. Now each orbit has a fixed distance from the nucleus. Okay. So when electron is revolving, it will also have some wavelength or some frequency, and some energies are also associated with this electron. Now we will go for next slide. What are the concepts? So it is the structure of atom. According to de Broglie's, this is the central part which is known as nucleus. Around the nucleus, electrons are revolving. So here, this is the central part which I have shown you by means of yellow color rectangle, and this nucleus is having the positively charged particle. Around the nucleus, electrons are revolving. So it is the orbit around which electron is revolving. So electron is negatively charged particle and nucleus is having positive charge proton. Now the distance between this nucleus and this radius, this distance, this distance between the nucleus and this first energy level. In that distance or in that energy level, electron is revolving. As the moving particle, when the electron is moving from one place to another place, it is having some wave characteristics. So electron is having or electron is associated with the wave. These are the waves which are associated with the electron. Now, as the electron is having the this characteristic, so it also must have some mass. So in there could be only allowed certain possible frequency, wavelength, and energy in an atom. So electrons, when the electron is revolving around the nucleus, it will have some frequency, some wavelength, and also it will have some energies. So de Broglie's come to concept that when the electron is having some mass and it is moving some velocity from one place to other around the nucleus, he proposed that he proposed the equation. The wavelength which are associated with this electron, he given that wavelength of electron by means of lambda. So lambda is the wavelength which is associated with the electron. So lambda is equal to h upon mv, where lambda is the wavelength in meter, which is associated with the microscopic particle like electron. V is the velocity in meter per second. So velocity is what? Velocity of an electron, because electron is moving around the nucleus, and of mass m is for the mass of an electron, and h is Planck's constant. Now the equation for de Broglie is lambda is equal to h upon mv, where lambda is the wavelength of microscopic particle like electron, h is Planck's constant, m is the mass of moving particle, and v is the velocity. Next is, now what is the use of this equation, or what is the meaning of this equation lambda is equal to h upon mv? This equation is the de Broglie's wave equation. So what we are using? So how many terms are there in equation? First is wavelength, which is denoted by lambda. Second is Planck's constant, which is denoted by h. Then m is for the mass of the particle, and v is the velocity. So is it possible to apply this concept to all the particles? For example, if I move from one place to another place, is it possible to apply this concept to me or human body? No, it is not possible, because the concept of de Broglie's equation is applicable only to microscopic particle. So all moving particle which will have the wave-like characteristics. So now come to the example. Now the cars which are moving, which are going from one place to other place. Another is the baseball. Next is, just a minute. So whether it is possible to, it is possible for the car, it is possible for the baseball, and it is possible to for motorcycle, which are also moving from one place to other place. So it is possible that these are also having the waves. If it is possible, then how? And if it is not possible, then why it is not possible to apply this concept of de Broglie's to the macroscopic or large particle? Now go for the equation. Lambda is equal to h upon mv is the equation for de Broglie's. The car and baseball are having the velocity as well as mass. Now applying this concept de Broglie's equation, we do get a wavelength for the moving particle. Now we will get the wavelength of the car and wavelength of the baseball if we apply this concept. Now go for solving the problem. Now what is the mass of the car? Now consider that mass of the car is about 910 kilograms. Now the velocity of the car is found to be 25 meter per second. Now the wavelength come to minus 2.9 into 10 to the power minus 38 meter. Now how big is this? This is very big calculation. Okay. Now this concept of the calculation of wavelength of the all the particle is not possible. So de Broglie's wave equation is applicable only to the microscopic particle. It is not applicable for the macroscopic or large particle. Now come to another example. What is the speed of electron? Electron speed is 25 meter per second. Now apply the concept to the microscopic particle like electron. So mass of electron is found to be 9.11 into 10 to the power minus 28 gram. Now what will be the frequency? What will be the wavelength? After calculation, it comes to minus 2.9 into 10 to the power minus 1 meter. Now it is very small, and it is possible that it is having 3 point. So it is having the wavelength which can be considered. Now go for the calculation of the what will be the wavelength of electron of having mass 9.11 into 10 to the power minus 28 kilogram, traveling at a velocity of 2.00 into 10 to the power 8 meter per second. Now we have to calculate the wavelength of the electron. Lambda is equal to h upon mv by keeping the values of mass m. So here we know that keep the value of m in equation. Lambda is equal to h upon mv. Keep the value of m as 9.11 into 10 to the power minus 28. Then h is Planck's constant, which is also given 6.63 into 10 to the power minus 34 joule per hertz. Then another is V is also given, that is velocity 2.0 into 20. Now keep this value in the equation. This equation lambda is equal to h upon mv. After calculation, we got 3.64 into 10 to the power minus 15 milligram. So this is the concept. So what is the concept of de Broglie's? De Broglie's has given the concept that all the microscopic particles are having the dual characteristics. Which are dual characters? Particle character as well as wave character. All the microscopic moving particle will have the wave associated with it, as well as it will also behave as a particle. So he come to conclusion that the de Broglie's equation is applicable only to the microscopic particle, not the macroscopic particle. All the microscopic particles which cannot be seen by naked eye are having the dual characters. First character is the wave character, another is the particle character. So equation of the de Broglie's is lambda is equal to h upon mv, where lambda is the wavelength of microscopic particle like electron, h is Planck's constant, m is the mass of electron or microscopic particle, and v is the velocity. De Broglie's applied his concept to the electron. So equation for de Broglie's is what? Lambda is equal to h upon m. So this is the de Broglie's wave equation. By considering the de Broglie's wave equation, we can calculate the wavelength associated with the electron or another other microscopic particle. Okay. Now this is all. So if we come to the orbital, it is found that first energy level is n is denoted is equal to 1. Second energy level n is equal to 2. Third energy level n is equal to 3, and n is equal to 4. So n is the principal quantum number. So it explains that electrons are moving in a specific energy level. So this we have calculated. So here the concept of de Broglie we have completed here.